have the coordinate to state in like this xy, we call this in the Cartesian system, right? And you would like to determine these in Cartesian and change to the another coordinate, which is called the polar coordinate, which is you have the represent the component of r and theta to represent. So where is this coordinate in this Cartesian? So you have the x for minus 3.5 and y as minus 2.5. So this is represent the position for these x like 3 minus 3.5 and minus 2.5 for y. So you like to determine this one, the position of these r and theta, right? In order to find r, you can have the components in x and y to square it up and sum it up together, right? Like this. And if you like to find the angle, you can use the relation of tan theta, and you determine the components, the ratio between the ay to ax, like this. And now if you like to find the r as initially, so now you can sub everything inside the square root. So here is like minus 3.5 square plus minus 2.5 square dot under the square root. So when you do the calculation, finally you get 4.30 in unit of meter. Or if it's not said about this, so you ignore it and state maybe like unit for this one, because there's no unit state, and you know just this as a coordinate, not yet distance or force for this case. And how about tan theta? You can use a ratio between that. Ay is minus 2.5, right? And ax is minus 3.5. So when you do this, the division, you get the final result as 0.71. But how about the theta? Theta, you can find the convert of the tan, we call the arctan of 0.71. Use the calculator, finally you get 0.61. Make sure you use it with the right unit. So they're going to be rad, gradient, or in the degree, right? If you use the radian, so it's gonna get this result out. Most of physics about the angle or gradient extraction, we rather use this radian unit to the degree unit. So if you can convert to degree, you're gonna get like 35.37 degrees, which is, you know, when the circle wrapped up for one round, the theta is 2 pi radian, right? Which is 360 degrees. So you can do this ratio to convert between radians and degrees. So this is how you get the r theta. So finally you convert from x, y to r theta. So you can write down finally as r theta is equal to is 4.30 and maybe 35 degrees. You can write like this way. Not only vector component you have learned, we still have some subtype of the vector to represent the direction in each individual axis. We use I and these like hatch signs to represent the unit vector pointing out into y direction. What is the unit vector? You're not seeing this Thai word. So unit vector is the vector that have size equal to 1. So we call that unit vector. So that means this I hatch, j hatch, and k hatch has size equal to 1. So there's no size for this vector. Only function of this vector are for pointing out direction. Right. So I hatch represent one unit of the vector pointing to x direction, j hatch is for y direction, and k hatch is for z or z direction. Most of the information here we will use this to represent the unit vector. So how you can write this a vector in terms of these small unit vectors. So this a combined with the components of a in x direction and component of a in y direction as well. So which is you already know ax is you cross this a here, so you got a cos theta out of it. So when you get it further away from theta, you got a sine theta. So you have the vector a here in terms of a cos theta I, and plus with another one a sine theta j. You can see use I and j to tell the direction, and in front of it is a component to tell the magnitude, how far or how long of this vector along x and y direction. If you write in 3 dimensions, you can have the components of a z in k direction. K hatch is in z direction. You can use I, j, k to represent the unit vector along x, y, and z. Also, some of the textbook you can find the x hatch, y hatch, and z hatch. These are the same in terms of meaning, so of unit vector. Okay, now you learn about the component of vectors and the unit vector. So here is what I said about if this angle like theta represent the angle between x-axis to another component, and this is like cosine size is the angle between the xy plane and vector. Now you have this vector a in 3 dimensions. You can break the component out of this one. So how can you do that? So if you like to find in z direction, maybe I write down like this in k position, which is z direction, right? Maybe like this. So how can you do that? You can break this further away from this psi angle. So in z direction you got a psi psi, and you would like to convert to the close psi angle. So that means you flip it to this plane, the xy plane. So when you flip it, it's close to the psi angle. So this is cos psi. So that means in xy plane, you got the value of this vector or the components. So these are components. This is in ij plane. That's it. A cos psi. But this already finished as the az, that the component in z direction, but this is not yet the component in x or y. It's still on the plane. So now you would like to flip this one, the one that point here, This is A in XY component, which is this one, AXY. So now you further maybe break this component to X and Y plane, which is, you already know, this is the theta angle to X axis. You break this close to angle. So now you get in I direction, the direction on X1 is AXY cos theta, which is AXY is above this one, is absolute A cos psi and cos theta, and this is your AX. So I rewrite this again, sorry for the mistaken. I will rewrite this to the components of it. Okay, this is direction, right? This is plane, in plane. This is in direction. This is in direction of I that. So you now got the first one is AZ or AZ, and another one is AX, which is equal to this term. And how about the in J direction, which is your AY. AY is equal to, you have AXY as well, and now you break to the further side of this theta, so you got sine theta. So this is now equal to A cos psi sine theta. So finally, if you like to determine the vector A, so you can have all the component in. So now you got this component A as A cos psi sine theta. Not sine, sorry, cos 1, because AX is here. Cos theta in I direction, plus the A magnitude of A cos psi sine theta in J direction. And the final one is magnitude of A sine psi in K direction. So this is how you write the vector in 3 dimensions. So you may not like completely get along or understand about this, but you have to revise it and try to figure out for yourself. And you can use and operate any vector in any dimension after this. So this is the key for vector that you're going to use in the physics and how to quantify the physical quantities later. And this is how you add it up. Like if you can break the components out of the vector, it's quite easy to add it, multiply it, or subtract it. For example, if you have this like graphical show of the vector B and A, if you like to find the A plus B, what you have to do, you have to translate this B to this position, like N head and N and head. So the resultant vector of A plus B is here. This is A plus B, which is the same as B plus A, right? So this is the graphical way, and you have to check the size of this, find the angle, whether what is this angle and what the angle between these. This is quite a little bit complicated. But if you do component breakout, in this case, if I break the components of A, so I break it out, I have A in term of X, A in term of Y, A in Y component, sorry. And I break this one as well. I break it, I have B in Y components, I have B in X components. So now what it can be easy, you can add up the magnitude in the same component each order, whether it's plus or minus, you can add them now. For example, like if this A1 is for example is if it's plus 2, oh sorry, if it's plus 2, and if this one is minus 1, so what is happened, you do algebraically calculate it, you got the plus 1 finally for I direction, right? And exactly same for y component and also z component. If they are in the same unit vector, you can plus or minus each other. So as you can see, for a plus b, you have the component of a and b in x direction, do plus or minus each other, exactly the same. And you have to write the unit vector to state about the direction on each axis as well. This is how you do the algebraic method on vector operation. Let's see on the example. Now if you have these 3 vectors, okay, I will put the arrows in it, hatch in it, because these are all vector and unit vector. So please define or determine this term. If you like to find D as term of A plus B plus C, minus C, you can sub all in like 2IH plus 4JH and KH, and you plus with B, which is 3IH minus 5JH plus 3KH. Now you subtract with the C, which is minus I hatch minus 3JH and plus 7KH. So what the final value you get out of this? So the easiest way to do is check the vector, unit vector first. You see I is over here, you can group it up. As you know, this is from I, and what are their components? So their component is 2 for the first one is A from A, right? And the second one from B is plus 3. And how about from C? Is minus 1, right? But you still have minus 1 in front of the bracket. So you multiplied it, so you got plus 1 for I components. So how about the J components? Do the same. You group it up and see 4 minus 5 and plus 3. And the final one, which is the Z components, with the K component are in Z direction. So you got plus 1, you got plus 3, and you got minus 7 for K. So finally you got the vector D out of it. So to quick sum it up, like 6I, and here minus 1 and 2J and 4, and then minus 3K. So this is your vector D. As you can see now, we don't need to write any graphical image. What we do algebraically way. We do algebraic way of calculation. So if you like to find the magnitude of D, A magnitude of D, not A. A is the article now, not this vector A. So would you like to find the magnitude of D? How can you find it? So magnitude is what you represent the component on each direction, right? A x, a y, and a c under square root. You square it up, sum it up, and do this under square root. So now got 6 square plus 2 square plus minus 3 square. So the result of this magnitude is square root 49 is 7. If you like to find the unit vectors of D, how can you find it? What is unit vector? Unit vector is what I said is represent the direction with size as 1. If you have vector A, you still have the direction, yes, but the magnitude of A should equal to 1. How can you change the magnitude of D, which is equal to 7, to 1? Yes, you do self-division. You divide by its own side. This is the unit vector of D. So I can put the hash into the D for 8 unit vectors. So now you get vector D and the side for a division. So it's 1/7 for the size of the vector D or its magnitude. And the vector D itself is 6i plus 2j minus 3k. So now you get your unit vector of D is 6/7i plus 2/7j and minus 3/7k. So this is the unit vectors of